All right, welcome our last official video here for the virtual learning for the fourth quarter for the year. So, obviously, if you looked at the heading, 10.4 and 10.7 quiz optional. Just a quick explanation of what that means. It is optional, 100% optional. It's not something you have to do. It's not. If you don't do it, it's not going to. You're not going to be negatively impacted. If you do decide or you're considering doing it, here's kind of the where it could potentially help you is if it's going to factor into your other quiz grades. So we did a 9.456 quiz, we did a 10.1 and 10.2 quiz. So right now those scores are getting averaged, and that's making up kind of your quiz assessment grade for an Infinite Campus. If you potentially had maybe a lower score there and you're looking to bump it up a little bit, that would be something that you would consider if say, hey, okay, I'm gonna do really well on this last quiz, that can bump up my grade. The flip, and I'm not saying that, I'm not encouraging this. Obviously I'd love everyone to do it, but if you're sitting really well for those quiz scores, because I'm still gonna score it and you're still gonna get a grade on it if you choose to do it. So. If you did really well on both quizzes, which is the case for a lot of students, and you're maybe near 100% on your quiz scores, it's not going to bump you up any higher potentially just because you're already near, or you already have a really high quiz assessment score in the grade book. So I guess the potential there would be it could only hurt you. So just be careful. If you're not sure, if you're like, hey, this is my grade, this is where I'm sitting, just email me. If you're, I'm not, like I said, I'd encourage everyone to do it. I'd like to score everybody's, but at the same time, I understand that being realistic, that not everybody's going to do it. And so just make sure you're kind of aware of how it would go in the grade book. And this would be, if you choose to do it, your third quiz of kind of the quarter of the virtual learning time here. And those three scores will get averaged together. So I'm guessing, just I guess to put it short here, the people that are going to do it are maybe didn't do so hot on one of the first two quizzes, one or both maybe. So I'll leave that at that. Okay, so email me if there's questions. I'll do like I've done with the other ones. I'm going to run through the 10.4 and then 10.7 assignments. I'll give you like a quick overview of what the quiz looks like, and that should be it. It'll be a shorter video. So I guess. Well, I'll wrap up at the end, and I'll give you my big final goodbye at the end. But so let's do the homework here. So 10.4, this was all those inscribed angles, and some of these were hard. The homework looked okay. It's hard to tell. Obviously, even on mine, there's not a ton of work, so it's not like I was asking for a bunch of work, at least on some of the problems. Some do have more, but problems like one really, I think is maybe the only one that could be a super easy problem. Or say, hey, I've got this arc measure out here. The big concept was an inscribed angle is half as large. So it's like, oh, I'll just cut the 84 in half, boom, done, 42. But I think kind of as you work through it, there was, they got harder, and there were some tough ones on here. So again, I know you can kind of check all your answers as I'm talking here, or pause it or whatever. So, but maybe some of these I would look through. Here's another one that I think is super easy. I think the biggest thing that people kind of miss or get screwed up on is they're not necessarily answering the question. So like here, whatever, just it's asking for the measure of angle G. So this interior angle right here, some people find just this arc measure and say, okay, I'm done. Measure of arc FD is 170, and then they're done with it. So you got to be careful, and that I'm just speaking on what I've seen in the past on quizzes, and that people misanswer. They don't answer the question that's being asked. So this is another good example right here. 5 that, the 30, awesome, double it, TV is 60, done, there's my answer, 60. But it wasn't even asking about TV, it was asking about arc VU. So you had to use that 60, you had to start with that 60, but then, rely on this being a semicircle and saying, okay, 60 plus another 120 gets me to that full 180 there. So there's a little bit of that going on. Just make sure you're watching that. I'll just kind of leave these here. I'll jump to 8 and 9. Those are, pretty quick ones we said, relatively easy. Here the issue with, with doubling this, and there's a couple different fixes you could have had for that one. So The third one here, or I'm sorry, the bottom of the front page here, you got your central angle. And again, it gets tougher when there's overlapping pictures, basically, you know, like, so if you're looking, you've obviously got an inscribed angle where the vertex is on the circle, and then a central angle where the vertex is the center of the circle. So I think this is a good illustration of just seeing the two side by side. So you've got your arc AC, 60 degrees, no doubt, okay? So the measure of angle ADC is 60, so I got to use the 60 on the central angle to get the 60, the same number out to the arc, and then I can use the arc cut in half to get the inscribed angle. So that's a really good illustration of kind of seeing the two on the same picture, because basically the central angle was 10.2, and then the inscribed angle was 10.4. So they're easy to mix up, okay? 11 through 13 involve this inscribed quadrilateral. The same thing, it ranged on difficulty level, like opposite angles being, like the big concept was opposite angles have to be supplementary. So, you know, obviously answering for X is 100. Sweet, 100 plus 80 is 180. You're subtracting from 180 here, 85. So that one I think starts relatively easy. Even here, your setup, 60, or, you know, however you want to do it, I wrote it as 2K plus this 60 opposite angles equals 180, solve for K, 60 plus M equals 180, solve for M. And then it jumps up to 13, like that. This was the one that we did on the notes, on the video, that where it's kind of a combination. I can't just do 3A plus opposite angle here. There's nothing there. So I had to get arc measures involved and inscribed angles. So you can kind of see the way that I did it, where I kind of doubled this angle and said that, hey, that's got to be the same as this measure right here, which I kind of represented up there. So there's different ways that, like we talked about in the homework, or on the notes about how to do those. So 14 ABC, there was questions on this. So I got a few on through email and through message and stuff. These are all inscribed angles, right? It says that all the inscribed angles are congruent. So basically, you know, if you were to highlight just one of them, because, like I said, there was questions on it, so I just want to make sure that that we're clear here. That, like, if I just picked one of these inscribed angles, let's say right there, whoops, and then obviously I've added these 72s after the fact, but each inscribed angle forms an arc. So the fact that these are all congruent means that all these arcs as well have to be congruent. So the problem is essentially starts right here. For each one, you basically need to count how many inscribed angles you have, 5, 7, 9, and take your 360-degree circle and divided the arcs up, or you divide it into equal congruent arcs with equal measures. So that's where the 72s came from. Here they were about 51 is rounded, and here each one was 40. And then going back, then remember the inscribed, we've talked about already, is cut in half, so 36. So that's where those numbers are coming from, as you can see there. This one is interesting. The sum of the inscribed angles on any circle, what's it going to be? 180, right? Because if the whole circle is 360 and every inscribed angle is cut in half, well, you're cutting in the of the arc measure, you're cutting the circle in half, basically, and getting the 180. Okay. 15, I think, was pretty straightforward. It's a little bit more algebraic, though. So there was kind of two ways to do this one. I've chosen to kind of double this angle, and it should be equal to this angle measure. You could also cut this one in half and say that that has to be equal to the 8x plus 10. So there was two. I'm not obviously going to solve that, but there was different setups there. And then probably the most questions I got on the homework was 16 to 22. This idea of inscribing a quadrilateral into a circle. So basically, for each one, you know, what I was kind of hoping for would we tie into some of those properties of quadrilaterals that we had talked about in the previous chapters. You know, so I mean, what has to be true if I draw a circle about every quadrilateral that I put in here, whether it's a square, whether it's a round, you know, whatever it is, we said the thing that has to be true is that opposite angles have to be supplementary, have to add up to 180. So if there's a case like that, a rectangle where I know the measures, 90 and 90, Well, definitely. And these are ones that you could draw, right? Like I'm not being exact, obviously, but I could draw a square and I think make it fit pretty well. Same thing here with a rectangle. You put some of your vertices a little closer together, but I think I can get a pretty good rectangle in there. So parallelogram is one though that if I try to draw like a true, or maybe you start with a parallelogram and say, okay, how can I get a circle to fit in here? Well, it's not going to happen because we didn't say that, that's an oval, right? That's not a circle. That opposite angles don't always have to be supplementary. They're congruent for sure. It's really when that parallelogram, you can see here, becomes a square or rectangle, right? Like as this starts to kind of tilt back this way and I start to bring the sides kind of back, it's going to start to square more up inside that circle. So parallelogram is not an always. Rhombus kind of falls into that category too, that if you draw your traditional rhombus where all your sides are supposed to be congruent, it's just not going to work out where you get vertices on the circle, okay? Isosceles trapezoid is kind of interesting, that just because of how it's drawn, that you're going to be able to get that one in there, that the opposite angles are going to be supplementary. And then same thing with a kite. Like you could for sure get a kite to fit in there, but not always though. Like I was trying to draw a kite, that's not very good. But like where two of these are the same, but it's not always going to fit necessarily. So it really kind of came down to that concept. You can see I reference it in just about every one, that the opposite angles being supplementary, because that was the property that we were using up here. Okay, so a little bit long there. I didn't want to spend that long, but I know there was a lot of questions kind of on this last section. So there's 10.4. 10.7, the last one, we kind of jumped, was all about this equation of circles. So it came down to those two big things that we said you needed to know: the center, the coordinates of the center, and the radius. So there was different, basically the whole 3/4 of the notes involved just different ways of maybe finding the center and finding the radius. So 1 through 6 here obviously involves just a graph. I can, pick it right off the graph. I can see the center, the center, the center. So I can see that. You just got to pay attention. Like I said, pay attention to the scale. So this is the 0.50. I still think it's important to kind of write out the center. So it's like, okay, 50. I can see the coordinates there. And then the radius, remember, you're going by 5. So 5, 10, your radius ends up being 10. All right, so I like to see them before I just jump from the picture to the equation, because then I know, hey, I got to square this to get this, and then these are going to be opposite. It looks like +5 here, it's -5 there, y -0, whoops, that's a mistake on my part, I forgot my squared there. Y -0 squared is just y squared. Okay, so that was the process here. Can we see them all? Yeah, I think pretty straightforward. Here, the only thing that maybe even easier, because 7 through 12, then you actually get it. Just here you go. Here's your center. Here's your radius. There's not even that element of trying to count and pay attention to scale. So maybe I should have started with these ones, where this is probably about as basic as you could get. You just would have to know your equation of the circle. This one more involves the simplifying. X plus 4y minus 1 squared for your 1 squared for your radius there. So just some of the simplifying, make sure like on something like this, x -0, y -0, we should simplify. Don't leave it x -0, y -0. Okay, here you're just going, you didn't need the center for this bottom one here. I pulled it out of there, but knowing your radius now, you can say, okay, hey, if that's my radius, don't square it, because that just puts you back at 16. But how in a circle is your radius related to your diameter? It's double. So if my radius is 4, my diameter is 8. 14, 15, 16, I know we kind of previewed these a little bit during the notes, but 0, 0, that's a nice point to have, because as long as you're going, in this case, straight up, where would these be on a graph? 0, 0, 0, 6 would be up here. What's my radius? 6. Okay, you got the center for free in every one of them. It was just more of, was the radius hard to find? So in this case, I did this one a little bit differently too than I showed, but I know we did distance formula between these 2 points right here for this last one to get your radius. Radius, ends up being 5. So if you did the distance formula, you should have found that the distance between these 2 points is 5 units, and then you would have squared it. We did things different, you know, and depending, had we been in class, I might have showed you a different way to kind of get to that radius, but whatever, it is what it is. So that was probably the toughest one there, a little distance formula. That's the way I showed it in the notes. Last couple, I knew there was one. I remember, same thing, I mentioned it kind of in the notes where we had ended up with one that just kind of shot off the page there a little bit. It was close enough that it was like, okay, yeah, it's not that big a deal. But this was kind of the only time that you were reverse engineering, basically, like here's the equation, identify the center, identify the radius, okay, put those on the graph, center, count, you're literally just going to count, don't count 16, we said you're counting 4, so 1, 2, 3, 4, kind of north, south, east, and west there to get your 4 nice points, and then just finish with the circle. So remember, these don't have to be in any particular order or anything like that. I'm just kind of listing out the 4 nice points that I know they're on my circle. So those are the last 4 there. They're graphing for 10.7. So quiz, what would you expect from the 10.4 and 10.7 quiz? Just the stuff we just went over. So it's going to follow, obviously it's just a 2-page quiz like usual, a front, back, or whatever. So not everything's going to be there. So you got to kind of, whatever. These first 6 are like the 6 on 10.4. I think this is maybe one of the harder parts of the quiz. 7 through 9, there, you know, you've got some inscribed quadrilateral, some algebra going on, show your work. And then it basically jumps to 10.7. So that's what you're getting from 10.4 on the front there, 1 through 9. And then the back would be the 10.7 stuff. So write the equation of the circle. We're just reviewing it. Here's the center. Here's a point on the circle. Write the standard equation of the circle. 13, again, we were just kind of reviewing that. It should be one that you can do. I did put, you know, in the past I've had this one on there. I'll leave it for you. It's kind of a challenge type problem. It would be, again, this would be something that you could do, and I mean, you would have to do the whole quiz or whatever. But if you did the quiz and you wanted to just give this one a shot, it's maybe worth trying to get an extra point or whatever. So there's the quiz. There's the homework review. I guess, I mean, I don't have a big thing or whatever, but it's been a good ride, an interesting ride for sure as far as finishing the school year and everything. So reach out to me, not just for school. If there's something that you got going on that's cool and you think I would want to know about it, feel free to drop me a line all summer, and obviously I'll see everybody next year. So that's what I got, and I'll hear from you, and you'll hear from me next time I see you. So, all right, have a good one.